All right, we've got our homework handouts out. And see, that's the way it's supposed to be. Anyway, you have your homework handouts out. We did the back side of the handout, which was number 4, a whole bunch of equations. And let's see how we did on these. Number the first, because they're not actually numbered. But the first problem, what kind of equation is that, Kendall?
Incomplete. Right? Incomplete.
Starts with a Q.
Quadratic.
Incomplete quadratic equation. How do we solve incomplete quadratics?
You isolate and then take the square root.
Isolate the x squared, take the square root. But there's 2 different x squareds, right? There's the 8x squared on this side, and then there's the 3x squared on the right-hand side. So when there's more than one x squared, what do we got to do?
Get rid of the little one.
If they're on opposite sides, yes. If they're together, of course, we just combine them. But they are on opposite sides. The little one's got to go. And how do we take care of getting rid of the little one, Kendall?
You subtract 3x squared.
To get
5x squared.
And while we're getting rid of the little one over here, moving the x squared, if you will, to the left-hand side, let's also get rid of the
14.
by moving it over as a
Negative.
to get
Negative 25.
from there.
You take the square root.
Not yet.
No.
We haven't isolated yet.
Divide by 5.
There we go. To get x squared equals.
5. Negative 5.
Then we can.
Take the square root.
And when we take the square root of x squared, of course, that's just well x. And then we try to take the square root of negative 5 because there's the square root of the negative.
You pull out your I, and then it's the square root of 5.
Oh, but minus a point.
Positive negative.
Positive negative anytime we take a square root. And how many have this answer, or these answers? Technically, there are 2 imaginary answers there. How many have these answers? Any questions? Look at the next one. What do we have here, Michael?
An equation, a complete equation.
Complete
Quadratic
equation. And with complete quadratic equations, almost always we start by setting them
equal to 0.
How should we do that?
Move the ones on the right over to the left.
To get?
6x squared, positive 7x, negative 20 is equal to 0.
And then from here we've got 3 choices, right? We could factor, we could complete the square, or we could use the formula. Which did you do?
I used the formula.
Yeah, I'm looking at this, I'm like, it's going to be a pain to factor. Maybe it does, I don't know. But I'm probably just going straight to the formula. A is
6,
B is
7,
and C.
negative 20.
And so we'll say that x is equal, just say the formula with me, class. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug in the negative 7 plus or minus the square root of 49. And that's a negative 4 times an a times a c, which actually gives me a positive 480 because the c was also negative, all over a 12. 49 and 480 adds to get 529, which you actually could take the square root of. That's a rational root. Square root of 529 is 23. So we end up with negative 7 plus or minus 23 all over 12. Which means it could have factored. So if you did the factoring method, that meant it would have worked for you. It just meant Michael didn't want to bother wasting his time trying to factor it when he knew this method would work anytime, any place. So we end up with a negative 30 twelfths. We end up with a positive 16 twelfths, which means my reduced down answers become what, Michael?
I didn't get that far.
Oh.
Yeah.
Should have got negative 5/2 and positive
1, 2,
4/3. How many got those? How many of you factored it? All right, so the people who got it factored it. All right, good. Again, I look at it and say, maybe it factors. I just didn't want to bother. So I'm actually with Michael. I would have gone to the formula. Questions? All right, on the next one. This is a special type of equation in Genesis called a...
We're going across.
We're going across,
Okay.
yes. Help? Proportion, yeah, it's a proportion. And to solve a proportion, we will. But as I look at those denominators, Genesis, it's like they're calling to me and saying, factor. And so instead of writing x squared minus 25, I'm going to write is equal to 3x plus 1 over
X plus 3x minus 1.
And the advantage of factoring is that because my factors that match are denominators, I can cancel them away. So we'll cancel away the
X minus 5.
which means when I take the product to the extremes, I'm just distributing to get
4x squared plus 12.
And when I multiply the means, I'm going to FOIL, but at least I don't have dissimilar binomials. At least they're similar to get.
3x squared plus 16x plus 5.
And all of a sudden now I have what type of equation?
Incomplete quadratic.
Well, I do have x to the first also. I have x squared and I've got x to the first. So complete quadratic. And for a complete quadratic class, we set it equal to 0. So Genesis.
Pull the 3 over
To get
1x or x squared minus 4x minus 5.
there we go. And now we want to, on this one, do we want a factor, formula, or complete the square? This looks like it'll factor really easily, so let's take it.
X plus 1 plus minus 5.
And when we set both of these equal to 0, we get.
Negative 5, negative 1, and 5.
However, one of these answers cannot be. Which one, class? X couldn't be a 5 or a negative 5 or a negative 3. So I can't include 5 as one of my answers. I can only go with negative 1. That said, how many have these two answers at least initially? All right. By the way, if you hadn't canceled this, you would have had 3 answers. Negative 1, 5, and 5. Both 5s had to go. How many realized the 5 had to go? Okay, a couple of you. All right, questions on this? All right, going down to the next row. This is not a quadratic, Maddie, but it's kind of like a quadratic-y thing. It's in quadratic form, we would say. So what do I do? To get?
X to the 4 is negative 12 x squared negative 28 equals 0.
And then?
X squared plus 3x squared negative 14.
All right.
And then you need to set each thing equal to 0. So then x squared plus negative 2 x squared equals 14. And then take the square root. And then you take out the I. But it's positive negative. And then square root 2. And x equals positive negative square root 14.
Yeah, kind of unsatisfactory. We get 2 imaginary answers and 2 irrational answers. No, good, nice, easy rational roots. But hey, they're still all 4. How many got these 4 roots on this one? Excelente. Looking at the next one. Audrey, we have a fractional exponent here, and I don't know what you call upside down. With Dex, it could be backwards. But anyway, we've got, actually, if you flip both numbers backwards. Anyway, we've got a binomial with a fractional exponent, a rational exponent. What do we have to do?
Raise it to the 5 halves.
Good, on both sides, right? Raise both sides to the 5 halves to get?
3x minus 4 equals 32.
But the denominator's even, meaning this is a square root of 4, and there's 2 square roots of 4.
Positive negative.
2.
2.
So when you raise them to the 5th power, we get 2 numbers.
Positive negative 32.
There we go. And from here to finish it, we're going to first,
Add the 4.
and that gives us 3x is equal to 2 numbers.
36 and negative 28.
And then
Divide the 3.
to get
12 and that.
yeah, negative 28 thirds. And how many have those answers for this problem? All right, excellent questions on that. All right, the next one's an absolute value equation. What's the key here, Abby?
For absolute value, isolate and then make 2 equations.
Good, using the positive negative. So, 5, absolute value 2x minus 1 minus 3 equals 22. Abby, talk us through it.
First, you add 3 to the 22 to get 25, and then divide by 5 to get 5, and make 2 equations to get positive negative 5.
I guess we could just do that, couldn't we?
Or, okay. And then you add 1, and divide all by 2.
Well, let's figure this out. So 2x is equal to what 2 numbers?
6 and negative 4.
And then when we divide the 2, we get
3 and negative 2.
and there's our answers. By the way, we don't really have to check this one. You could, and they would both check. But you don't have any variables outside and inside. It's just variable inside. So where these answers are both good to go. How many have these answers? Here. By the way, if you can't remember when should I check, when shouldn't I, we'll wait till the end of the exam and then do all your checking, but check whatever you want to, feel like you need to. When in doubt, go ahead and check. But again, do it after the exam. Don't check as you go, otherwise you'll waste too much time. Okay, so check as you need to, unless it's an inequality, because you have to check to know what to circle. But you don't have to wait till the end. Look at the next one. We've got a couple radicals. So speaking of checking, this is a problem where we're going to need to do some checking with multiple radicals. Brandon?
First, I moved over the negative as a positive, so square root of x minus 4.
Good. We want to isolate the radical, but since there's two of them, we want to isolate a radical, one of them. So he moved the negative over to the other side as a positive. I like that move.
And then I squared everything, both sides.
Good. Don't square everything. Square both sides. There is a difference because when I square here, of course, well, I'm squaring the only thing to just get.
X plus 3.
But if you think of squaring everything, you'll square the first and you'll square the last, but we would forget to. Right, so we need to think of it as squaring the binomial to square the first, square the square the last, but we then need to multiply and double.
Positive 2 times square root of x minus 1.
There we go. There's some simplification we can do here, Brandon.
I canceled the x's. And I combined the 1 negative 4 to equal negative 3, and I moved it over as a 6.
Good. Well, moved it over as a positive 3, which gave you a 6 over here, equal to 2 times the square root of x negative 4. So real quick, combine to get negative 3, move it over as a positive 3, go with the positive 3 to get to 6. Keep going.
Divide by 2 to get 3. And then I squared both sides.
Good. Square both sides again, now that we've isolated this radical. So isolate this one, square both sides. Work it down the way I isolate this one, now square both sides again.
9 over 6 minus 1.
And so we get
13 because x equals 13.
good, but again, if there's multiple radicals, we've got to check. Let's see if this works. 13 plus 3 class.
16.
16 square root of 16 class.
4.
4. 13 minus 9, or minus 4. 9 square root of 9.
32.
4 minus 3 equals 1?
Yes. Yep.
Yes, it does. And so there we go. Questions on this? How many got that answer? 13. Found that it checked. All right. Moving on to an inequality, we've got a pretty basic inequality here. In fact, my 8th graders will have a problem similar to this on their exam. So not a hard problem at all. Kendall, what do we do?
You subtract 5x.
To get,
2x.
at the same time,
Subtract the 2
to get.
negative 20. And divide away the 2 to get negative 10.
Should I have flipped that inequality sign, class?
No.
No, because I didn't divide by a negative. I divided by a positive 2. I happen to divide a negative by the positive 2, but I didn't divide by a negative, so don't flip anything. We could also say x is greater than or equal to negative 10, but it really doesn't matter, because we're going to write our answer as an interval, Kendall.
Negative infinity. No.
X is bigger. So that means not down to negative infinity, but up to positive infinity. So start with the
Negative 10 to infinity with bracket and parentheses.
there we go. How many had this answer for the inequality? Questions? All right, let's take a look at the next one. We have an absolute value inequality. And remember the key here. We looked at one of these the other day, a couple of these the other day. If your absolute value is greater, you're going to go outside the positive negative. If it's less than, you're going to go inside the positive negative. So you're going to get a negative 4 times the absolute value of x plus 2. Plus 9 is less than 1. Michael.
Subtract 9.
All right.
Gives you negative 8. Then you got to divide away the negative 4. And that gives you the absolute value of x plus 2 is greater than 2.
Good, we're dividing by a negative, so we're going to flip the inequality, and then negative 8 divided by negative 4 gives positive 2, which is really good. Because if this had still been a negative over here, class, with greater than negative, we would say
No solution.
all real numbers. Less than negative, no solution. But it's greater than positive, so we don't need to worry about that. It wouldn't hurt at this point to draw a number line and put your positive 2 here and your negative 2 there, and the x plus 2 going where, Michael?
In the middle.
Ooh.
On the outside.
On the outside, because it's greater than now. It was originally a less than, but because of flipping it, because of dividing by the negative, it goes outside. So I've got 2 little inequalities now, Michael. I've got everything this way, which I could say means x plus 2 is
less
less than negative 2, or I've got this range, which means
x plus 2 is greater than 2.
there we go. And when I subtract the 2 everywhere, I end up with
Negative 4
x is less than negative 4.
and 0.
X is greater than 0. How would I write that then as an interval or a pair of intervals?
Parentheses, comma, negative, parentheses, negative infinity, then negative 4. Parentheses, 0, and then infinity.
And there would be my answer there. How many got this? Questions on that? All right, and the last one we had is very recent. Polynomial inequality here. And Genesis, ideally, when we've got these polynomial inequalities, we'd like to set them to 0 and factor. But will this polynomial factor?
No.
No, I mean, it's 4 terms, so grouping would have been my only recourse, and it don't work. So. What do we got to do?
PQ method.
Yeah, what's the first number we should try?
1.
Of course, as I look at this, Genesis, everything's positive, right? Which means the number just keeps getting bigger and bigger and bigger if I plug in in general, if I plug in anything that's positive. So I'm not even going to waste my time with the 1. I already know it won't work. In fact, I won't try any positives at all. I'm only going to try negatives, the first negative being,
Negative 1.
and let's hope it works. What would be my next negative I would try?
Negative 2.
Not with a 15.
Negative 3.
Negative 3. And after that,
Negative 5.
negative 5. Heaven help us if we get to negative 15. And then we're into the 1 half, 3 halves, 5 halves, 15 halves because of the q value, the 2. But we're going to try negative 1. And when we plug in a negative 1 here, that gives us what?
Negative 2 plus 13 minus 26 plus 15.
And does that equal 0?
Yes.
All right, I'm really glad that worked. All right, so the negative 1 checks out, which means we're going to do some synthetic division. We're going to do some factoring, but factoring is division. We're going to synthetically divide to figure out these factors. And of course, remember, put the root itself in the half box. We could say a factor is x plus 1. We just had no way of knowing that before. And we'll list out all of our coefficients beside it, draw the crisscrossing lines, bring down the 2, and then
multiply.
what you get?
Negative 2.
Add
11. A negative 11. 15. Negative 15. 2x squared, 11x, and 55.
And now that we're here, I'm really hoping I can take this quadratic and factor it. And so let's try to factor this thing here in Genesis.
X plus 3, 2x plus 5.
And we check that outer, inner, and sure enough it works, which means those are all my factors. Now again, do you have to make this list? No. But it might help us to see there are 3, not answers, because it's an inequality. Genesis 3, what do we call them, class, anyone?
Separator points.
Separator points or critical points, right? We're going to go to the number line, and we're going to plot all 3 of these. So we're going to first of all put negative 1. So it zeroes right here. Again, it's not a critical point, but negative 1, we're going to put a closed dot.
Negative 3.
Negative 3, I'm going to put another closed dot.
Insert that equals 5 halves.
Careful, negative 5 halves, which practically speaking, negative 5 halves, class, in plain English would be negative 2.5, which is just absurd. All right, and so I've got 3 points. That's going to give me 4 ranges. What are they, Genesis?
Negative infinity to negative 3. Negative 3 is negative 2.5. Negative 2.5 is negative 1. And negative 1 is positive infinity.
Of course, we'll always use parentheses on the infinities, and because of the or equal to, everybody gets,
Parentheses.
ooh. Think of this or equal to straight line as the straight lines on the bracket. Okay, so you see the or equal to, think straight lines here on all of my brackets. All right, I definitely don't want to test something in here, but I could test something in here really easily. What's a good easy number we could try, class? 0. And if I make zeros, that gives me 15 is less than 0?
No.
All right. It's another number we could test. -4 would fall in this range, all right? So calculator at the ready, if you haven't already done it. Cube that gives us, call it as you have it. -64 times 2. All right. Square the -4 times 13. How much? 208. All right. -4 times 26. And then plus 15. We add that all together, and it looks like it's coming out negative, which would be less than, am I right? Comes out to negative something? That's less than 0, so this range works. Now, I'm pretty sure, what's the other range that's going to work, Genesis?
-2, -2.5, -2.
I'm pretty sure it's going to be this one. Because it can't be outers, inners, because this outer's already been ruled out. And this outer is checked. So it's got to be alternate. So surely it's this one, but just to make sure I didn't mess up my math here, let's test a value between -1 and -2.5. What's a value that might fall inside this range? -2. And we'll try -2. So we cube it, times 2. We square it, times 13. We multiply by 26. Well, that's convenient. And then we've got a positive 15, and look at that, just comes to a negative, doesn't it? So that means this range does work like I thought it would. That means without checking anything, I can rule out that range. And there we go. How many got that for the last problem on the handout? Questions on this problem? A lot more involved than the others, okay? Just by nature of the problem, questions. All right, page 153 in your textbooks. Page 153 in your textbooks. And I want you to practice with a couple more of these radical equations, numbers 43 and 44. They're on page 153. So Brandon, just make sure I see it tomorrow. Both of them check. No extraneous roots here. Questions on these? How many could go on both? Got them both right. How many got at least one correct? All right, any questions on the one we missed? All right, dropping down to the next section right below those problems, I want you to do 1, 3, 5, and 7. They're at the bottom of the page. 1, 3, 5, and 7. numbers up there. Good, okay. All right, for sake of time, check the answers to the ones you got done, and then maybe glance at the one or ones you did not get to and see, if there are any questions at all on these. Again, these are similar to what we did on the homework handout already. Any questions on any of these? As far as what to do, how to solve them, any questions? There will be just a couple word problems on your exam. Your homework this evening is going to be to complete a short handout with just 2 word problems on it. If you're watching on YouTube, look in the description of the video. You'll see a link to the handout there. Your homework for this evening is the word problem handout. As needed, go back and check your notes. Make sure you know how to solve word problems like these. These are similar to what you'll see on your exam tomorrow. If you're watching on YouTube, again, this is lesson 87. Tomorrow we will have about a 30-minute review lesson, lesson 88, which will go over this and also finish up any last review. And the exam will be lesson 89. All right. Well, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.